So I think we'll go ahead and get started. I just wanted to welcome everybody to our webinar today. We're really happy to have Chris Skoglund here from the New Hampshire Department of Environmental Services to our New Hampshire Food Alliance webinar. For those of you who have not attended one of our webinars before, the New Hampshire Food Alliance is a statewide network connecting food system professionals, from farmers and service providers to folks that work in the distribution, hunger, advocacy sectors. We are working to help promote a resilient, equitable, and healthy food system across New Hampshire. And we host monthly webinars to help better connect folks across the state with work that is happening. And we also have people generally who join us from across the country. So I think we can go right ahead and welcome Chris. Thank you so much for being here today.
So thank you, Erin, Sam, and Jennifer for inviting me to participate today. I'm really excited about this. This is a topic that's very near and dear to my heart, even though it's not kind of within my day-to-day work. It's something that I've think about quite a lot, somewhat in part from the fact that I'm a child of a failed back to the land effort on the part of my parents, who moved to Vermont and then 7 months later came scurrying home to New Hampshire, bringing me and maybe a few leftover canned tomatoes from the summer. The overview from the presentation today, just to kind of give you a sense of where we're headed, and I always find this is helpful because I tend to do presentations as more of a story than a kind of a scientific talk. Really want to just consider what is climate, what are some of the local and state observed changes, but then because we're talking about food, really kind of consider what might be some state and national, as well as international changes and impacts that may want to be considered. By looking at all of these, we can begin to think about opportunities to respond, the various considerations that we need to take into account in choosing actions to secure our food network, and the opportunities that might be there. Now I'm going to preface the rest of the presentation as to say that this will be light on solutions. One of the intentions, or that's somewhat intentional because this is meant to support an effort over the next year or for the remaining, or for the foreseeable future, addressing climate change as part of the food system will require constant reevaluation and development of solutions. And so this is part of an effort that we're doing in the Food Alliance to incorporate considerations of climate change across a bunch of different areas of their work. Some of the key ideas that hopefully you'll take away is that global warming is real, it's serious, it's already happening. The solutions to the problems do exist now, even though I'm not going to get into them. They're becoming more cost effective, and as more people pay attention to them, they're becoming, there's more solutions that are being identified every day. But some of the things that we do need to take into account is whether we choose the solutions, that prevent the causes or manage the impacts, it's our choice. And any delay that we take will just make those solutions more costly going forward. So a little bit of my background. I'm currently the Climate and Energy Program Manager for New Hampshire DES. It's a relatively small program, and my work actually straddles both mitigation, which is addressing the causes of climate change. And in that capacity, I work on a limited basis with local municipalities, but then I've also worked with all the states in New England and the provinces of Eastern Canada on how do we reduce greenhouse gas emissions. But then my secondary focus is supporting incorporation of climate adaptation considerations into state and local planning and policy. And this food work is a recent part of that. A little bit of the mitigation, but will probably be a lot of the adaptation. My background, prior to this, I was an environmental science educator, and I've pretty much worked with every age group, working with kindergartners as well as working with seniors up to the age of 95. Primarily, I was a classroom teacher, but I've also worked in the permaculture space as teaching a about this topic and actually giving the presentation, or the original version of this presentation. But I've also been a lab tech, an organic farmhand, a lifeguard, a server, and a busboy. So as you go through this, one of my claims is that I have no delusions of grandeur as well. I'm a scientist. So please don't hesitate to ask clarifying questions, and then feel free to continue the conversation afterwards. I'll have my information posted at the end. But I'm also, I taught 7th grade, so I can handle any sort of questions. What I want to do is just run through a couple different things just to kind of recognize where we're at, and put this presentation in context, and note that it's been a tough couple years for those that have been following what's been happening in the environmental space and the climate space in particular. In 2017, there was a lot that we were focused on with Hurricane Harvey, which in under a week dropped 4 feet of rain. Hurricane Maria, which set Puerto Rico back decades in terms of development of its infrastructure, society, and economy. There were widespread wildfires in California, and here in the eastern US, we had extreme cold during the winter, which has been referred to as the polar vortex. Skipping ahead 1 year, we saw a repeat of many of those same headlines. Tropical Storm Florence was a direct hit to North Carolina, creating a lot of the same flooding that we would see, but to a lesser extent than Harvey. Hurricane Michael hit Florida with similar force to Hurricane Maria. We were introduced to a new term, the bomb cyclone in the Northeast, where we saw, I think, at least 3 nor'easters hit in the month of March, just repeated storms. And the wildfires in California were of a magnitude that shocked the nation and possibly the world, killing upwards of 40 people and leading to the power outages that are now being planned for California. In fact, I think today the planned power outage failed and a new wildfire started as a result of winds there. So 2019, it's been actually a tough couple months in terms of reading the headlines, and they seem to be back to back for those of us that follow them on a daily basis. The UN reporting that up to 1 million species are at risk of extinction, in part due to human activities more broadly, but very much due to changing environmental conditions from a warming globe. But then human activities are also increasing the toxicity of the environment, and we may lose a significant amount of insects and honeybees in particular. Climate change becomes a cofactor in driving this risk. Up to 40% of our forests are at risk of warming that can increase the chance of infection due to insects, and this can then lead to another risk, which I'll touch on later. But also during all of these, we're seeing that the month of 2019 was the months of 2019 were among the warmest on record. And in fact, tipping points have begun to be reached around the country. There's been a lot of talk about 2 degrees Celsius warming as being a significant risk for the globe as a whole. But already we've begun to see that within various parts of the country, where as you get, this scale goes from blue to red, blue being cooler than normal, red being warmer than normal, and red approaching that 2 degrees Celsius warming. But not only has it been getting warmer, but as the humidity has been increasing, our extreme heat indexes have been increasing around the country as well. So we've been seeing heat waves where, with the relative humidity added in, the heat index approaches the point where humans really, it's not healthy for humans to spend time outside. This image here just kind of shows, without a scale, unfortunately, those areas which are most at risk, which you can see in the south, but areas of the north are warming as well. But it has been so warm, in fact, that parts of the Arctic have caught on fire, and during June, wildfires were ranging in North America as well as Asia, north of the Arctic Circle. which were new. We also then got reports from the UN that a significant number or populations across the globe were at risk of a water crisis. And then this was paired with risks to the global food supply. Water is inextricably linked to food, and as water supplies dry up, and just for those of you that are panicking, this is not how the presentation is going to go. This is just setting the stage. But even though there's some areas where water is becoming less available, as we saw this spring and the summer, there was a significant amount of flooding that actually ended growing seasons in the Midwest before it even started. And as a result of all of these, climate change has been identified as having the greatest impact on agriculture compared to any other sector across the globe going forward. And that is a significant problem because already changes in weather patterns, warming of the globe, and climate change have been linked to populations around the planet beginning to migrate from areas where they can no longer sustain themselves. And this has been directly linked to the influx of migrants, not just from Central America and South America, but from India and Africa that are arriving on our southern border, making their way through Mexico. So all of these environmental impacts are actually tied to some of the broader US policy debate that we're seeing. So I present that because that's what we see in our day-to-day. And it leaves that sense of, for many of us, a sense of despair. And one of the things that we can actually use that as that information provides us with an opportunity, because looking at all of that together, it helps us understand the various considerations that we may need for planning in the future. And those considerations can help us identify opportunities to work on our own and work together or learn from one another. And it's important to remember that we have, as a nation and as a state, made significant progress over pretty gross environmental degradation in the past. Here we have a picture of, I think it's the Merrimack River, showing a picture of, back in the 60s when the mills were openly dumping pollutants. You could tell what color textiles were being dyed by the color of the river on any given day. And then with the passage of the Clean Water Act, that body of water is now fishable and swimmable. And it can be used as a source of water for municipalities throughout central New Hampshire. So that's an important consideration, is by recognizing the challenges, we were able to address them. Sorry, that was the Nashua River. But with all of the different kind of headlines that I just shared, there's a lot of different complex interrelated issues that were thrown at you all at once with just a lot of pictures and a lot of headlines. And if anyone is interested, every single one of those slides does have the linked article to it, and I'm more than happy to share that. None of this presentation is my original work. But there's all of these different issues that do kind of interrelate and feed on one another. The two that tend to pop out, and this is where I spend a lot of my personal time, if not so much my professional time, is the issue of food security and climate change. They are all related to every single one of the concepts in black, but they are looking at kind of two ends of the scale, climate change being a global and a local issue, but food security being very much a global and a local issue as well. And I tend to focus on food because it's one of the key elements for our survival. When I used to lead wilderness trips, we always talked about the rule of threes, and you can survive 3 minutes without air, 3 hours without shelter in extreme situations, 3 days without water, but 3 weeks without food. But in college, we talked a lot about self and society, and the things that were needed in order to have achieved fulfillment. And at the very base of that pyramid, this pyramid, which is called Maslow's hierarchy of need, it's noted that without food, we cannot achieve kind of these higher level elements of our society or self. Hungry people, hungry individuals, they don't get along as well. Anyone,
I'll wait till you're done.
a 3-year-old knows that once they get hungry, all things break down, society being not that much different. But as our population grows, that puts pressure on our global food supply. And it's, as we've seen since the Green Revolution, our population has been growing rapidly, in part because the food supply has been growing with it. Climate change puts pressure on that, and that's where the intersection between food security and climate change occurs. The reason why this is important to New Hampshire and the New Hampshire Food Alliance, and this is where I actually began to track the work of the Food Alliance before they invited me to participate, is there had been an assessment through the New Hampshire Food Vision of what exactly New England's food supply was. And they estimated that New England's farmlands were able to provide 12% of the region's food. And that is a challenge because as the population in New England grows, it puts pressure on that farmland. And even with that 12%, it's been estimated by John Carroll from the University of New Hampshire that we have 3 days worth of food supply on hand in the state. So we actually are relatively food insecure because we're so dependent on food trucked in from out-of-state supplies. So this image just shows that it was an estimate for population growth in the 2030s of if population grows, prime agricultural land may be developed. So that puts the twin pressure of more mouths to feed with potentially less prime agricultural land being available if we aren't able to protect it. So this is just kind of setting the stage for pressures that are on New Hampshire, but then climate change becomes a threat multiplier because this image here shows the world as it has been warming on average. And I'll talk a little bit about kind of the unequal warming that we've seen. But what I want to do is kind of put climate change through a bit of a wheel and take this conversation, and I'm going to have to skip a few slides because I'm realizing that some of the edits that I made last night didn't make it into this version, which is my fault. But take you through some different steps of understanding how climate change is connected to human activity, how that's connected to global temperatures, and how that directly impacts New Hampshire and the region, so that we can then begin over the next couple months, years, and decades, respond to that in order to protect our most vulnerable citizens and our populations as a whole, ensuring that they get adequate calories and nutrients in order to thrive. So I'm going to skip through this just for the sake of time and assume that everyone knows that climate change is based on a well-established greenhouse gas effect, where sunlight comes in, heats the earth, and then carbon dioxide and other gases trap a portion of that heat in and make the earth warm enough to sustain human life and liquid water. That process is largely driven by greenhouse gases such as carbon dioxide, which we have been tracking since the 50s and know has been rising, and it shows this rising and falling on an annual basis continuously, and has reached 415 parts per million at its peak this year, having started at 320 back in the 50s. We also know that looking further back, 400,000 to even 800,000 years, carbon dioxide in the atmosphere never got above 280 parts per million. And these dips that you can see where it rose and fall between about 180 parts per million and 280 parts per million, each of those dips is paired with an increase in temperature or a fall in temperature on the range of 10 degrees Fahrenheit or Celsius. So each rise and fall of carbon dioxide was paired with the beginning of an ice age, the length of the ice age, and then emerging from an ice age. So each kind of gap here, or U, represents an ice age. And this goes back 800,000 years. So instead of 4 ice ages, we would have, or 4 glacial periods, we would have 8 over a period of 800,000 years. Now, human activities have been increasing the principal greenhouse gas, which is carbon dioxide. There are other naturally occurring greenhouse gases, water vapor being among them, but CO2 is among the most important because it remains in the atmosphere for centuries, whereas other greenhouse gases have less of a lifetime. Almost everything human activities touch can impact greenhouse gas emissions because of its connection to fossil fuel combustion. But agriculture and land use also release carbon dioxide as soil carbon, and carbon in trees and plant matter can be disturbed and released into the atmosphere. So what we've seen is at the start of the Industrial Revolution, carbon dioxide was at about 280 parts per million, and then rose to a level of, this slide is slightly out of date, it should say 415, rose to a level that has not been seen in about 3 million years. And explaining how we know and can count backwards 3 million years is another presentation unto itself. But there are numerous proxies that can be used for temperature, and they have all been validated around the globe. But what this shows is that we are well outside of the range that has been seen in the geologic record. And that has been driving an increase in global temperatures. This shows global average temperature. So that's temperature averaged over winter, summer, spring, and fall, as put together by the Berkeley Earth Project. And it's validated by data sources from NASA, NOAA, and the UK Hadley Center. So it's not just from a single source, but it shows since the beginning of the Industrial Revolution, when greenhouse gas emissions really began to be affected by population growth, land use change, fossil fuel use, temperature began to rise slowly. And what this is showing is it's showing temperature rise compared to the global temperature anomaly. And that anomaly is the kind of change from norm or normal. And that normal is set between 1950 and 1951 to 1880. Climate averages are measured on a 30-year period. So you can see there's that relative flat period following World War II. But then in the 1970s, that temperature did begin to rise and has been rising steadily since. There is interannual variation. Other presentations could explain the cause of that. But we did see our peak temperature in 2016, and almost every one of our warmest years has been since the beginning of the 20th century. 1998 is the remaining outlier, and 2019 is expected to be somewhere between 2018 and 2016. As I mentioned, numerous months this year have already broken the global average temperature for that, or broken the global temperature for that month. So one of the things that we do get punished on pretty severely whenever giving any sort of presentation is this notion of the polar vortex. Because we have had some pretty severe cold weather days that not just get low in temperature, but low in duration. And they were pretty severe during 2014 and 2015, and then 2017 as well. 2018 had a little bit of a lower temperature. This image here actually shows real temperatures at 1 p.m. on January 20th of 2019, showing most of the country was locked in very cold temperatures. One thing to note throughout this presentation and in any time that anyone is talking about this subject is it's important to remember that the climate is not the weather. The weather is a set of conditions at any given time, today, tomorrow, this week. Especially this time of year, you wake up and it's 35 degrees outside, and by the end of the day, it's 65 degrees. We can have some wild swings in weather. Climate is the average set of conditions, and as I mentioned, it's measured on a 30-year average, and the baseline that is most commonly used by the scientific community around the globe is 1951 to 1980 because of its relative stability. But we understand climate in the sense that my wife has bins downstairs that are for fall, winter, and summer clothes for the girls. So we are currently putting away the summer clothes and pulling out the fall and getting the winter ready, and then taking out the things that no longer fit and then giving them to our friends, neighbors, and relatives that are interested in those garments. And we know those clothes work because we have been living in this climate. We know that winter is very cold. Whereas when we were living in DC, they had a different climate and we didn't have a lot of the warm weather gear. We would actually wear clothes that looked quite similar. Another element about the Earth not warming evenly, about the polar vortex, is the Earth is not warming evenly, and I'll explore this in a lot more detail. This shows the amount of heat that has been absorbed by the ocean between 1960 and 2015. It's a terrible image because it doesn't have a lot of explanation to it, but it shows the amount of heat that has been retained by land, ice, and the atmosphere, which is important because only 25% of the Earth's surface is covered by land and ice, landborne ice. And the atmosphere is relatively thin and can't hold a lot of energy relative to solid substances. But when we look at this image, including the oceans, which are both significant in their area that they cover, representing about 75% of the Earth's surface, as well as their depth, up to 2,000 meters and more in spots, they can hold a lot more energy. And they have been absorbing about 90% of the retained energy from the greenhouse gas effect. So as more CO2 has been added to the atmosphere, as our greenhouse effect has been growing, a lot of the temperature increase that we've been seeing around the Earth has actually been moderated by the oceans. So they prevented the atmosphere from warming as fast as it otherwise might have. So the impact of that warming trend that we have seen is that not only is the land and the oceans warming differently, but different parts of the Earth are warming differently as well. So what this image shows is winter of 2014. We can see that the eastern US and eastern North America was actually very cold, but significant parts of the rest of the globe were actually very warm. And this shows this, there's keys at the bottom showing the change from that 1951 to 1980 norm for wintertime, December, January, and February, where purple is 4 degrees Celsius below average, and deep red is almost 7 degrees Celsius above normal. And what it shows is in 2014, 2015, and then 2016, we did have variation in weather, which is kind of the winter temperatures varied compared to that 1951 to 1980 average. But overall, the globe as a whole was warmer than it had been. If you look in the upper right-hand corner of each image, you can see the number that has no key attached to it, 0.65, 0.83, 1.2. This is the warming that was experienced compared to that 1951 to 1980 baseline average. So we were seeing temperatures that range between 0.7 and 1.2 degrees warmer than average. 2016 was the warmest year that has been recorded so far, and the winter was warmer than average as well. If we look at the average temperature for all seasons from 2013 to 2017, and this uses a slightly different visualization tool, we see that same uneven warming where the northern hemisphere is warmer than the southern hemisphere, but the Earth in general has warmed compared to the 1951 to 1980 baseline. So when people talk about climate and they talk about weather, it's important to remember that weather varies from year to year, but the climate in general is getting warmer and warmer compared to that 30-year baseline average. One of the reasons, something that's important for the Northeast to be considering, because of where we sit, because we can experience the polar vortex, is why we actually get the polar vortex. How that uneven temperature variation influences us more deeply than maybe other parts of the globe. And what that comes down to is changes in the jet stream. The jet stream normally goes west to east. And when, back in the 1950s, 1980s, the temperature differential between the equator and the North Pole were extremely different. So one was very warm and one was very cold. And that temperature differential actually created a very strong jet stream that acted like a tight belt, so that cold air in the north could not interact with warm air in the south. But as the Earth has warmed, you noted that a lot of the warming relative to 1951 through 1980 had occurred in the north, and some of the greatest warming had occurred in the Arctic Circle. That doesn't mean the Arctic Circle is now warmer than the equator. It just means that it has warmed more compared to its own average. So if the Arctic Circle had spent more time at the -10 degrees Fahrenheit or Celsius, it has warmed on average 10 degrees, where the equator has warmed just 2 degrees. So what we've seen is, as those temperature differentials have dropped, the jet stream has weakened, and as it's weakened, the belt has become looser and has kind of begun to droop occasionally, allowing cold air to spill south. And in some cases, it can dip very, very deeply, allowing warm air to rise up into places like Anchorage, Alaska, and allowing cold air to spill very far south into like Georgia. So what we've seen in some cases is that the Iditarod dog sled race has actually had to be moved north to find areas where there's snow, or even bringing snow into the end of the race to make for those telegenic moments. But at the same time, cold air that should have remained over the Arctic Circle has now spent time spilled over the Northeast, and made for very, very cold winter nights for an extended period of time. This image was January 4th of 2018, which is actually very similar to the polar vortex event that we had in January 20th of 2019. Both of these were produced by a tool available through the University of Maine. So that focuses on some of the changes that we're seeing in the globe. But what we can actually see is, how do those global changes have an impact on New Hampshire and the Northeast? And what we've seen is that there's been an increase in overall temperatures in the Northeast, much like we've seen across the globe. And those changes have been occurred both annually and seasonally. We've seen an increase in precipitation overall, both the amounts and the intensity, and that we've seen not just an increase, but a change in the precipitation, where more has been coming as rain overall, and more of that precipitation has been falling as in winter rather than in the spring and the fall as it may have in the past. We've also seen an increase in extreme weather events and a change in our seasonality. I'm going to go into more detail on each of these topics, with the exception of summer drought. I haven't been able to find as much information on this, but we have seen more summer drought. And this is one that may seem perplexing at first, because we talk about more precipitation in general. But when we think about increasing average temperatures, and we think about more rain coming during the winter and less snow falling during the winter, we actually have less year-round available moisture, because rain falling in the winter on frozen ground tends to run right off rather than soaking into the soils. So it's not available during the year. And the warmer temperatures will dry the soils out faster during the summers, when there may be less available rainfall than in the past. 2016 was a significant drought year that exemplified many of these points. Because it was one of the warmest winters on record, we had very little snowfall remaining into the spring. So if we look at this, a lot of the next sets of slides come from the Climate Central website. They use data that's available from many different national agencies, and therefore it's verifiable through multiple sources. But in using them, they have a tremendous amount of images that kind of help understand what is happening across the country. What is helpful is that they have data that's available for every state and then multiple municipalities within certain states. So this image here shows average temperature change within the seasons, showing that between 1970, which is when temperatures began to really, temperatures and the global climate really began to change, we do see winter warming in New Hampshire really accelerating compared to the other states. Fall has warmed as well, but spring and summer have not warmed as much, but they have still gone up by 1 degree. And I apologize for not having the units posted here, but based on other reports that I've read, this is in degrees Fahrenheit. So winters have warmed by about 4 degrees more than 4 degrees Fahrenheit, where summers are a little bit over 1. And if we look at Concord, New Hampshire in particular, this shows the average wintertime temperature between 1970 and 2018, showing that for that individual municipality, the temperature has risen on average by 5.6. We do see the interannual weather variation as the temperatures are colder sometimes and warmer on others. But in general, the average wintertime temperature, which would be that December, January, February timeframe, has gone up by about 5.6 degrees. And for Concord, New Hampshire, we've also seen a change in the long-term, or a change in the hardiness zone. We've seen a change in what are the coldest days for each of the years. Between 1950 and 1981, the coldest days were in the range of -20, and between 1989 and 2018, they rose significantly and were above -14, moving into the -13. And this isn't our average temperature. This is just the lowest temperature that would be achieved during each of the different years. And you can see it's pretty consistent. There's not as many dips. And what this translates to in terms of those hardiness zones, and I apologize for this image, they didn't do a terribly good job of thinking about contrast, and they used all green. But if you watch very carefully, you can see that this change in the lowest temperature, not the change in average temperature, but the lowest temperature has actually caused a shift in the hardiness zone for the entire United States, and that, New Hampshire has actually moved into having a new zone move into it because of that change. So this has implications for growers as well as the ecology as a whole for the United States and New Hampshire. When we look at snowfall, snowfall's been a little bit more variable. This is just for Concord, New Hampshire, but we can see actually that it shows that there's been a little bit more snow falling between 1970 and 2018. And that spring warming has been occurring. The average temperature has been a little bit warmer. One of the things that I wanted to say here that will have implications for later is we do have a little bit more snowfall in total for Concord. As a state as a whole, we are seeing less snowfall. But as the winters get warmer and as springs get warmer and as snowfall gets less, one of the things that we are seeing is that there's less days with less continuous days or less total days of snow cover for the state. This does expose our soils, our forests, our ag lands to more freeze-thaw cycles, and that has significant impacts on perennial trees, shrubs, as well as the quality of the soil. This is kind of gets to that point in Concord, New Hampshire. We've seen an increase between 1970 and 2018 of 34.8 days above freezing, going from just over 110 days to about 145 days over freezing. This has benefits to the growing season, but it does have some potential negative implications when we begin to talk about soil quality, that freeze-thaw cycle that may be interrupted occurring, as well as pests and invasive species. This shows the wettest days of the year. We've seen an increase of almost an inch on our rainfall of our wettest day of the year. 2 inches may not seem like a lot, but if you imagine 2 inches of rain falling in a 24-hour period, that is a significant amount of rainfall. But on average, we have seen almost 3/4 of an inch added to that. So it's more than a 50% bump in the extreme precipitation for any given worst rainfall day. But we've also seen a slight increase in days over 90 degrees, rising from about 11 in the 1970s to 13 or 14 days in 2017. That is projected to go up more, but I'll touch on that later. So the human scale of these impacts, because these are largely just the environmental impacts, have been noted in that article. Like I showed this image earlier, but it notes that agriculture in the Northeast, we're seeing that strong shift in seasons, winter most of all, and it's going to have impacts on insects, pests, and wildlife. But there are other things that we also need to consider as well. The impact of public health, bringing those ticks and insects into perspective. As it gets warmer, mosquitoes are able to transmit more diseases more easily. And what you see is that as we get closer to 90 degrees, the percent probability of them being able to transmit a disease if they are carrying it increases to almost 80%. It drops off pretty quickly as the temperature gets warmer, because mosquitoes are small and they can't handle the temperatures, and they may just go hide and wait for it to get cooler. But as temperatures within the state get warmer, and we did see the number of days over 90 increase, the incidence or probability of disease transmission grows. Another risk is not just transmission from an infected infected mosquito, but it's also the number of days where humans are at risk of being infected. In the 1970s, we had just over 90 days where mosquitoes would be flying, and we now have 19 more days. A significant increase of more than 20% in the number of days where mosquito-borne illnesses may put people at risk. So this includes not only individuals that are, just in the regular community, but farm workers and others who we depend upon for our local food supply, but also our national food supply. If you think about New Hampshire being a relatively cool climate, these numbers become even greater in parts of the South where the growing season is already longer and days over 90 or in the range of 90 are already higher, and where new diseases may become endemic, like Zika and dengue fever. The days above freezing also have implications for ticks. I know in the past year, 3 of my neighbors just within 3/4 of a mile of me have all been diagnosed with Lyme. And I have gone from not ever seeing ticks when I was younger to pulling 3 to 4 ticks off me a day if I am in the field. And some of what is driving that is the winter warming temperatures, where we have seen that change in temperature of 5.6 degrees on average. It makes it easier for them to survive. Consecutive days above freezing also makes it easier for them to survive. But it also makes it easier for their hosts to survive as well. So it's not just the ticks being able to overwinter, but it's mice and deer finding winters to be more palatable or survivable. So it is kind of a complex system impact. But it's not just on the ecology. Impacts to infrastructure are also taking a hit, as we have seen more extreme storms, whether those are ice storms. The picture on the bottom the bottom, is actually from the seawall along the New Hampshire seacoast following one of the March nor'easters. In the upper right, we have a wastewater treatment facility that was inundated on 3 different occasions over a period of about 18 months. each of these elements are connected to the health and welfare of our communities. But the impacts to extreme weather to infrastructure can then also have impacts to our food supply, whether it's food that is grown in the state or food that is grown or imported. Anyone that's ever been in a grocery store right after a storm hits know that it's pretty well cleaned out. But also, if we have extended power outages, as we did during the 2008 ice storm or other ice storms, food supplies may not last as long, whether they are stored in bulk or they are stored in at grocery stores or they are at home. The 2008 ice storm, we kept moving. One of the reasons why we kept moving was we were trying to keep our frozen food frozen. Ultimately, we failed. But those are the sort of larger impacts that we may need to think about. Other ecological impacts that people are beginning to pay attention to and talk more about that may not come to mind because they are ocean-based is the fact that the Gulf of Maine, which I haven't talked about at all, is the fastest warming body of water on Earth. Part of it has to do with its location in the north, and the north is warming faster than any other part of the globe, but also it's kind of own self-contained body of water. And so what we have seen is that lobster have been shifting in their range rather rapidly. What may seem like a small change in temperature to us is actually the difference between them and viability. And so they were quite robust a few years ago in the small New Hampshire seacoast, but have since begun to move further and further north into Maine. The winter shrimp fishery has, from what I understand, collapsed, and it was closed, and it may never open again. But we have also seen changes in fish populations. In the bottom left, we have what's the black sea bass. And in even discussing with the Commissioner of the Department of Fish and Game, he's noted that his own lobster traps have been empty of lobster, but he's been catching black sea bass instead. They've come around the Gulf, the Cape, and they're becoming an endemic species down here. They may actually be a species that we find the state having to make a determination of whether they regulate the harvest of, but it's an indication of the ecological change that's happening here. Some of the other changes that we're seeing because of changes in our climate in New Hampshire include the 2018 loss of the peach crop. While we may have more days over freezing and fewer days and more warmer winters, our vernal window is becoming a little bit more irregular because we are still in the north. We are still at risk of a drop in temperature through a change in the jet stream, bringing cold air down from the Arctic. So we saw a warm spell that allowed many buds on various tree species to open. And many peaches, in fact, flowered or their buds began to open, and then a cold snap occurred, freezing them at a very vulnerable point so that virtually the entire crop was lost. We're also seeing similar impacts through the vernal window to the maple syrup industry, which has become more irregular as days may warm too rapidly and not fall enough at night. One of the impacts that we are seeing is as our average temperature increases, it's not getting as cool at night as it once did. So the drop in temperature between day and nighttime, whether it's in the winter, spring, or summer, is not occurring. And so that is reducing syrup runs. So I'm realizing I have no idea what time it is. Just want to touch base on, this is where we stand with the weather and climate impacts across the globe and in New Hampshire. But some of the work that has been done at UNH indicates that the decisions that are made by New Hampshire, by the US, and by the globe will determine what sort of fate we will experience going forward. And so some of the food system planning that we may need to do is thinking about where we expect we might be, but where might we need to plan in order for safety? So what this image shows is for northern New Hampshire, the average annual temperatures from, and it shows kind of that baseline period 1960 through 1980, 1950s were dropped off. But you still see the flat period, but then in the 1980s, the temperature begins to increase. Both of these are modeled runs. The blue run shows a low emission scenario where, assuming the world emits far less carbon dioxide, the red line is a projected run or modeled run that shows what would happen if the Earth were to experience greenhouse gas emissions that continue to grow, where we do not abate our activities through things like renewable energy and changes in land use and building practices. And what we can see is that under the lowest emission scenario, we may still see the temperature rise another 2 degrees Fahrenheit. We've already seen New Hampshire in this out to 2020 go from about 54 or 53 degrees Fahrenheit in the 1960s through 1980s to about 55 today, where we could get up to 57 by 2040 and then 58 by 2100. So that's, if we've already seen 2 degrees of warming in New Hampshire, imagine what another 2 degrees of warming might do. They may seem like small numbers, but this is our average temperature and represents a significant amount of energy and ecological change. If, however, there is no mitigation, there is no or far less work to address greenhouse gas emissions, we may see warming that takes us for a total of 10 degrees Fahrenheit and brings us to a very different climate. To give you kind of a sense of what these changes might be like, the blue line represents a climate similar to that, or at least from a temperature standpoint, of Pennsylvania, where the red line represents a temperature-based climate similar to that of North Carolina. We would still be coastal and we'd still be within range of a potential polar vortex. So while the temperatures may be warmer, we would see some variability that cannot be modeled as easily in a single chart. So in the future, we do expect it to be warmer, but it's a matter of what do we prepare for?
So Chris, I'm just going to interrupt for 1 second. This is Erin. It's just a couple minutes to 1, and
okay.
some folks who are listening may need to hop off, but I think we should continue because we are recording this, and we will send everybody an email with the link to the recorded talk. But if people do need to, you're welcome to stay. Obviously, if you do need to jump off but have questions, feel free to just type them into the chat and Chris can get to those at the end of the presentation as well. All right, thanks, Chris.
Great, thank you, Erin. The other 2 things that I do want to draw everyone's attention to, and I think these are the ones that kind of catch my attention the most, is what might actually be happening at the national level. Recognizing that our food supply, as much as we would prefer it to be local, may prefer it to be local, is dependent on outside sources. As an earlier slide noted, we have 2 to 3 days worth of food supply within New Hampshire, conservatively estimating, and that we may produce 12% of our total food supply within New England. But what this image shows is days over 95 degrees across the entire continental United States, as evaluated present day, and might be experienced for someone who was born between 1981 and 2010. And so this was a study done through an organization called Risky Business, and back in 2014. I've since tried to find an updated version. But what I've noted generally is where we grow wheat, corn, and soy, where they're primarily grown within the US. So I apologize for the very rough mapping of this. But we also grow about 25% of the vegetable supply in portions of California. And I left those 2 markers in place to note that as we go forward, and you'll note that as we go from green to purple, purple being 250 days over 95 degrees, so basically Death Valley. Green in the Northeast being almost 0 days over 95. Going forward, it is projected that the United States will begin to see a very different set of conditions. So by mid-century, 2040 to 2059, we could see a lot more days over 95 degrees within growing regions. And it's over 95 is when growth of important crops begins to slow, if not stop. And by the end of the century, we could see areas where 125 days out of 90 or over 95, so significantly impacting the growing season. Some places, like in Texas, become half of the year over 95 degrees. And it's not just corn, soy, and wheat, but these are also important areas for cattle and other crops and livestock. So the implications of increasing temperature have impacts outside of New Hampshire, but have direct impacts on our food supply. And some of the things is, as the temperature increases, soil moisture decreases, fire risk goes up. We've already seen fires within the fields of France this year that impacted, I think farmers were actually ordered out of their fields to reduce the risk of injury and death. Another thing that has also been investigated is the chance of megadrought. These are droughts that last 1 to 3 decades. At the time that I had put this together in 2016, California had already been experiencing a drought of 5 to 6 years. But the colors here indicate the risk of a megadrought occurring in parts of the United States. The lighter the color, the lower the risk. But to give you a sense of, the risk, portions of Texas are modeled to experience between 80 and 90% likelihood of experiencing a megadrought, where other portions of the Midwest are above 90%. And so this doesn't just affect their food growing, it also affects water supplies. It also affects their own ability to grow food within their borders, not just those central growing regions. So this has a potential cascade of effects on populations. I know Cameron Wigg from the University of New Hampshire has observed that he's worried about internal migration driven by water stress, as areas where folks may be living now because of a palatable climate may find that it is just too hard, too hot, and too thirsty. So I can, in theory, end here, noting that the local climate will be more stressful, and that we are going to have more temperature that are warmer. It's going to be wetter overall. Our season may be longer, but it's going to be drier. We may have more frequent and intense extreme events, but there's likely to be new diseases and pests. Already my friends in Vermont are experiencing some sort of new fruit fly that has made a mess of their cane and blueberry crops. So they're kind of, even though they're to the north, they're still on the front line of invasive species driven by warming climates. But national and global food supply regions will be more stressed as well, therefore stressing food supplies here, even though it is not locally grown. So there's a need to both look at the local and the national and the global. And so Aaron, I don't know if we want to pause there and see if there are any questions that may benefit everybody. I have a few slides that do just kind of note that even though I've painted a rather dark picture, by understanding all this and thinking about all these together, there are opportunities to pick out solutions in the short, medium, and long term, but then potentially partner with other states in the region to kind of think about this. So as I noted, focusing on the Nashua River in the beginning, like, we have tackled environmental problems that seem to be larger than any one person or any community or even any state could address. the Nashua River couldn't have been done without state and federal action. Smog pollution was addressed. I've been to Thailand and experienced what it's like in countries that don't address air pollution from vehicles, and found the 2 days that I was in parts of Bangkok to be almost unlivable, and enjoyed the rest of my trip outside. But with just simple technology, we were able to reduce smog 30 to 50%, and in a very short amount of time, and increase air quality. A global problem, smog is actually a local problem. A global problem was the ozone layer. 40 years ago, we were working on this. This required international action, and the ozone layer is actually rebounding. And it just simply required the identification of the problem and folks rallying behind it. Acid rain was a similar problem. It actually had a national cause, and it required a national market-based solution, but it was reduced very cost effectively and resulted in forests and lakes rebounding. So we did see massive ecological impacts, but those were addressed. And now, because of the fact that kind of the world is waking up to as a whole, is waking up a little bit more, and I'm more optimistic than I've been in probably 10 years in terms of climate action. That's a whole other presentation. But while we saw a bunch of clips talking about the threats that we are experiencing and the ones that can sort of drag you down, there are numerous studies that are being published that once you understand a problem, you can begin to understand what are the leverage points that we can attack. So 3 days after the UN report talking about food and water crises, the New York Times and others published a series of solutions. So this was just an article in the New York Times, easily accessible for many different audiences. But then the World Resources Institute had come out prior to that, almost in anticipation of the UN report, noting that there's a variety of technologies that can feed the world, and I guess they note without destroying it. I guess comparing it to the fact that so much of the way that we grow food now does have a detrimental impact on soil, does have a detrimental impact on water, and that by modifying these cultivation techniques and looking to new solutions, we may be able to feed the 7 to 9 billion mouths that will be around at the end of the century, but do so in a way that does not impair future food supplies. But they go further because they have a lot of analysts, and they are actually able to quantify how that impacts greenhouse gas emissions and land use change, and show that we can be benefiting the food supply as a whole. So this is the sort of thing where, it's reports like this that the Food Alliance, Food Solutions New England, and other food networks can look at how do they reduce greenhouse gas emissions, but then also how might some of these improve soil tilth and recycle nutrients so that we can actually be boosting food production as well. And then there's others that are looking at, and these are just, I think this is a stock image. These are just soil tillage radishes that actually are able to improve soil health. But there are opportunities for us to look for new crops that may be able to thrive in a changing environment. They may be more adaptable, they may be more resilient, or they may have a longer history and a broader genetic heritage that we need to be exploring. This would require changes on the part of farmers, but also changes on the part of the US public. Going back to Thailand, when I was in the streets, I did eat quite an American diet, but there were quite a lot of different foods that I had never tried before. So it may require us to think differently about what we eat in order to sustain ourselves and sustain the future. And I think I'll just end on noting that innovation, once you begin to kind of push, does come rather quickly. The telephone started out as this big boxy thing, and by 2015, we had incorporated a computer a Magellan GPS device and a telephone, a computer, and a DVD player all into a single device. And that going forward, it could be something even more dramatically different and transformative. It does have its positives and negatives. As anyone who's seen a kid get addicted to the phone, but innovation can happen, and so there is a reason to be optimistic. And so I'm just going to pause there and see if there have been any questions that have emerged. Noting that the focus of this was not on solutions, but it was trying to identify what are the considerations that we may need to take so that we can have that in-depth conversation about solutions we need to be considering and the systems that interact.
Thank you so much, Chris. This has been such a great background for me, definitely, and I imagine for other folks as well. So we do have a question here from Charlene. Thanks, Charlene Anderson from the Community Loan Fund, who thanks you for the informative presentation. She's wondering if, Chris, if you're aware of any studies being conducted in New Hampshire or the Northeast that are looking at how to address competing demands for watersheds and how that may impact food supply.
So when she's talking about competing demands, are we talking about drinking water, and irrigation in that sense?
Yeah, I don't know, Charlene, would you be willing to unmute yourself and clarify, or you can just type it into the, you're unmuted, Charlene, if you want to go ahead and ask your question.
Yeah, thanks. Chris, yeah, I'm thinking specifically kind of the groundwater on our groundwater, you know, from municipalities, businesses, you know, agriculture enterprises, other food enterprises.
So I am not, but I think this becomes one of the ones where a concern that because of the work that I'm able to do, I am a somewhat unique individual within the New Hampshire Department of Environmental Services, where I work directly with the drinking water and groundwater folks. And in fact, they have just started their own climate resilience team made up of 3 individuals, one who's looking at, you know, groundwater, one who's looking at water treatment, and another who's looking at water conservation, but they then represent and are interacting with all the other individuals. So I think that is a sort of question where I can help carry that to them and make sure that they are thinking about that. But it is always something that, you know, DES is looking to balance. In our laws, in our rules, we're required to kind of take those into consideration, and that we're doing groundwater withdrawal sustainably. But it's a complex issue because now we do have emerging contaminants. We need to make sure that withdrawals aren't disturbing those. And then recently we've begun to note that sea level rise is actually causing seawater to move into the coast under and affecting groundwater. So there is this system that we need to be considering. So that's a long answer of saying no, but I would be more than happy to kind of bring that to the folks that I'm working in consultation with. Somewhat like I am with Food Alliance, I don't have answers, but I basically just help ask them questions to get them using their experience and expertise to bring to that issue. But it is one that I would agree we need to be absolutely thinking about, especially if summers grow drier and hotter.
Great. Thanks for your question, Charlene. Anybody else have any questions? I don't have any more in chat here, but if anybody else wants to unmute themselves and ask a question, now's a good time. I would love for you to talk for just a minute, Chris, about what you're working on with the Food Alliance. I didn't give much of an introduction at the beginning about how your work with us, what you're actually doing with us right now, but and I know we're still in process, but if you could just let the group know a little bit about what you're working on there, that would be great.
Yeah, happy to. So one of the things that I am hoping to, or will do, is to take a significant part of the information behind this presentation and put it into a briefing document that provides background for and that's accessible for any audience to understand what kind of climate change has for direct and indirect implications for New Hampshire's food system, food network. But I then recognized that the individuals that I might be pulling into that discussion, they may be, more climate scientists and environmental scientists who can talk about what's happening to the environment, what's happening to the climate, to our average weather patterns, but what the implications are on vulnerable populations, what the implications are on food and markets. That is something that I have found to be best put in the hands of the actual practitioners. So 3 significant projects that I've done within the state. One was developing the Climate Action Plan in 2009 for New Hampshire, which was entirely a stakeholder-driven process. We did have consultants that did some data crunching, but they did it under the auspices of more than 125 individuals that provided the assumptions, that vetted the options for addressing the causes of climate change. Similarly, we did that for New England and Eastern Canada, coming up with another plan, broader in scope, but it really required stakeholders who understood the energy systems to be giving ideas on how the region as a whole can be collaborating to address the causes of climate change. That then cascaded into a parallel effort to how do we address the impacts of climate change as a region. And it's something that I may actually continue to try to get food as a consideration of. But then within New Hampshire DES, we worked with all 25 bureaus, giving them a list of the causes and impacts of climate change and asking them, which ones are you related to? How are you related to? What are the impacts of that relation? How can you respond? And I think that asking the other groups that are working within New Hampshire Food Alliance to kind of consider those questions will result in a kind of a secondary impact statement within that briefing, and then hopefully result in a set of recommendations that would be shareable with decision makers. So basically I'd be helping other individuals within the Alliance facilitate that kind of review, doing the bulk of the drafting, but really the idea generation, the solution generation has to come with people that understand vulnerable populations, has to understand land availability, land preservation, and the other kind of topic areas that Erin, Jen, and Samantha are kind of carved out for us to work on. There may be some areas that we end up developing that are totally unique, but I think that's part of the discovery process. It's putting together the brief.
Great. Thank you, Chris. So we had a question on the chat from Benji, who's wondering what the Food Alliance is doing to encourage local communities to build resilience and sustainable food systems that will adapt to or mitigate these mostly disastrous climate effects that we're expecting. So I think what Chris just described is one of those things that we are trying to do as an alliance, and Chris is helping spearhead this effort to bring people together across the state who are involved in the food system, but I think also in other sectors as well, to come together and start coming up with policy recommendations, and also just other recommendations for what communities can be doing to mitigate and build resilience. So that we're working on this coming year. I would also say that we have a lot of other groups. The New Hampshire Food Alliance is sort of an umbrella organization, and then there are a lot of groups across the state that are doing some really interesting things that we are then trying to share throughout the state. So Vital Communities, I don't know if there's anybody on the call right now from that group, but they are starting up a farmer network to look at climate adaptation and resilience. And Chris, I think, are you going to be giving a similar presentation at the launching of that farmer to farmer network?
So yes, I actually am. I'm going to probably tone it down a little bit because I don't have as much time.
Yeah.
But that's great to know. I'm actually working with vital communities on a whole thing. So I work very closely with Sarah Brock, and she's a great resource.
Yeah, so I think, so Vital Communities is doing this pilot program of getting this farmer to farmer network together. And I think that would be something that if that's successful, that model could be replicated in other places across the state. Our conservation districts also are doing a whole lot around soil health initiatives. And so there are things happening. There's not, as Chris sort of has mentioned, not necessarily a big statewide effort around, from the state government anyway, around food and climate. But I think that's the role that the Food Alliance is trying to play right now.
And I think one of the things that strikes me about this is that, and I tried to find an image that matched, but the way we can look at climate is many of the things that I talked about are narrow, deep holes. There is not like as we're walking kind of in the dark. We don't necessarily know where the holes are, when they're going to hit, and if we fall in them, the impacts will be severe, and it's going to be hard to recover from them, like hard to crawl out of that hole. Depending on the profile of greenhouse gas emissions, will determine the number of holes that are in our path. But I think if we think about what are the ones that we are most likely to reach first, or how we might experience them and who might be impacted, that might be helpful. Because quite honestly, we have tremendous amount of food in this state and this country. We waste 40% of it per year. I know in our house, our chickens are fat and happy on the leftovers that I can't always foist off on my kids. But if we think about who's going to be most impacted by a sudden spike in food price, if France were to experience, a fire, if the Midwest were to be flooded, and then Australia and Ukrainian food supplies were to be busted as well, not everyone in New Hampshire would notice that, because food may be a small portion of our budget. But there's others that are not as equally safe in their food security. By looking out for them, for the most vulnerable populations, kind of as a all consequence or all hazards approach, and just saying it doesn't matter what the cause is, looking out for them is a way of securing them for when climate impacts may become more common, more likely. And then we build from that. So we don't necessarily have to make everything about climate, but just putting systems in place to ensure that we are addressing childhood hunger, we are addressing food security for people that may be out of work, almost as if it were a recession or something.
Right.
And
Yeah.
so you don't have to use the word climate change, because sometimes that doesn't get very much traction
Right.
in certain places.
Right. That's a really good point. Well, Chris, thank you so much for being here today. Really appreciate this really informative and detailed talk. And I hope that you'll be able to use this. I know you've gotten calls from all across the state of people wanting you to come in and talk with them. So hopefully this recording will be useful to you as well. And thank you to everybody who was able to join us today. Again, we'll send out an email with a link to this, so feel free to share the talk with your colleagues and your communities as well.